Welcome to the AI Research Roundup. I'm your host, Alex, and we're here to explore the latest developments in artificial intelligence research. Today, we're diving into a paper titled DeepResearcher Scaling Deep Research via Reinforcement Learning in Real-World Environments. Essentially, this paper introduces a new framework called DeepResearcher. It focuses on training large language models to perform deep research tasks by learning directly from interacting with the actual web, not just simulated environments. The key takeaway is that they're using reinforcement learning in these real-world settings, which they argue is fundamental for developing robust AI researchers that can handle the complexities of the open internet. And speaking of the framework, the authors have actually open-sourced their work. This image here shows the official GitHub repository for DeepResearcher. You can see the typical repository structure with folders for data, scripts, and the core source code. It looks like they've provided everything needed, installation guides, evaluation scripts, basically making it possible for others to replicate their results or build on top of this DeepResearcher system themselves. Pretty cool to see it shared like that. Okay, so looking at the results, this first figure here gives us a comparison of DeepResearcher's performance against other methods. The blue bar represents DeepResearcher, and the orange bars are other approaches like RAG-based models or simpler search methods. Along the bottom, you see different question-answering datasets they tested on, like NQ, TQ, Bamboogle, and others. What's really clear is that DeepResearcher, the blue bar, consistently scores the highest accuracy across all these different datasets. It really seems to outperform the comparison methods quite significantly in many cases, which supports the idea that this real-world training approach is effective. Going beyond just the performance numbers we just saw, this figure actually gives us a peek into how DeepResearcher thinks. It shows these detailed reasoning traces. On the left, you can see it demonstrating planning ability, breaking down a complex question into multiple steps like identifying a composer, then their birthplace, then finding a bridge. And on the right, it shows cross-validation, where it doesn't just trust the first search result, but actually does more searches to verify the information before giving the final answer. These aren't explicitly programmed workflows, but rather behaviors that emerged from the training itself. Okay, so digging a bit deeper into how this all works. This figure gives us a look at the actual system architecture. We saw the reasoning traces before, right? Well, this shows how the system manages to do that. It takes a whole batch of questions, like 256 of them, and processes them in parallel using a distributed cluster. For each single question, it actually runs multiple independent attempts. They call them rollouts, maybe exploring different search paths. And this all happens interacting with the real web, search engines, and actual websites via a specialized browsing agent that reads the page content. The bottom part shows that iterative process again. Think, search, browse, think, answer, repeating until it's confident. Building on that architecture we just looked at, this figure gives us a window into the actual training dynamics. You can see on the left plot how the performance measured by F1 score generally increases as the training goes on. And what's also interesting are the middle and right plots. They show that the number of tool calls, like searches or browsing actions, and the overall length of the generated response also tend to increase during training. It seems the agent learns to be more thorough as it gets better. Yeah, so we saw some examples of planning and cross-validation before, and this figure shows a couple more really interesting emergent behaviors. On the left, you see reflection. The agent realizes its first search results aren't quite right. They're about the wrong person. So it actually reflects on that and refines its search query to be more specific. And then on the right, it demonstrates honesty. After searching and browsing, it concludes it can't find the exact number requested and explicitly states that rather than guessing. Pretty advanced stuff emerging just from the training. So yeah, seeing those emergent behaviors like reflection and honesty really highlights the potential here. I think the key takeaway is how DeepResearcher uses reinforcement learning directly in a complex real-world environment, the web, to learn sophisticated research skills. This really pushes the boundaries of what AI agents can do autonomously, moving beyond simulated worlds. It's a big step towards agents that can genuinely help us with complex information gathering. Well, that's all for today. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.